Chapter 10 is bringing us into conics. It'll start by introducing and just simply using lines in this section, 10.1. Very, very simple section in terms of lines. So the first topic here, the inclination of a non-horizontal line is the positive angle theta, less than pi, measured counterclockwise from the x-axis to the line. Okay, x-axis to the line, counterclockwise. We can find the slope m of a non-vertical line with inclination theta as m equaling tan theta. Right? If we sketched it out and drew triangles, it would make sense as to why that ends up being a tangent relationship. So an important note is that if m is positive, then you're simply using theta equaling arctan, or tan inverse, I like to write instead. If m ends up being less than 0, theta is going to need to equal pi plus that tan inverse to make sure that we are where we need to be. Because theta needs to be between pi over 2 and pi there. Okay. So just a side note, it doesn't always come up, but I thought it was important to point out. All right, this next slide is just a picture of kind of where we're headed. Right, if we took a look at these and we thought about rotation, and that's also where it goes when you enter the world of calculus in the second semester at least, we do have things that rotate, and when things rotate, they form circles. So in this case, you're forming cones. So that's where we're headed. We're certainly not there yet in this section, but it's important to realize that it all can begin with a line, right? A line with a non-zero slope. So first example, find the inclination of the line, 5x minus y plus 3 equals 0. I left the answers visible just to save us a little bit of time with calculations. All right, we'll refresh on how to use the calculator to get these exact answers. You can refresh on the conversion between degrees or radians. But ultimately the skill is we need to identify what's the slope of this line. So quickly put them into mx plus b always. Don't try to do it in your head. Just take that extra moment. And in this case, I'm just adding my y, and I have y is equal to 5x plus 3. M then is 5, which is positive. And then I can go right to my formula that 5m would be equal to tan theta. I then take tan inverse of 5, and that would equal my theta. So in your calculator, depending on the setting, the mode that you're in, you would get an answer of 78.69 degrees or 1.373 radians. Does everybody at this point here, I'm sure you know how to enter tan inverse, do all those things? Okay. Questions so far? So that's straightforward. Inclination, you use the formula m equals tan theta. Angle between two lines. So if two lines have the inclinations theta 1 and theta 2, where theta 1 is less than theta 2, and theta 2 minus theta 1 is less than pi over 2, less than 90, then the angle between the two lines is theta equals theta 2 minus theta 1. Okay, pretty self-explanatory there. Now, how do we go about finding that, though? Right. So the nice thing is we can bring in, because we're using tangent, right? M is equal to tan theta. If we're talking about differences of thetas, we can bring in the identity, the tangent of the difference of two angles. So tan theta equals, because of what we were just talking about, right? Theta equaling the difference between theta 2 minus theta 1. So then tan theta is tan theta 2 minus theta 1, which would be equivalent to tan theta of 2 minus tan theta of 1 over 1 plus tan theta 1 tan theta 2. It's one of the trig identities that I'm sure you saw earlier this year. You streamline that because that's a little bit messy, right? Well, tan theta 2, that's just m2. We're going to pull that from the line. Tan theta 1, that's just m1. We can pull that from the line. Divide by 1 plus m1 times m2, and that is the absolute value because we're looking to find the positive. Okay, then we would do inverse of it and find our answer for what that angle is. So this would be something that you would want to memorize. So let's apply it. Find the angle between the two lines. Line 1, 2x plus y is equal to 4. Line 2 is xy. X minus y is equal to 2. They're already labeled as line 1 and line 2, so when we extract what our m's are, let's go ahead and make sure that we're consistent with the same thing. So put them into y equals mx plus b form. So y is equal to negative 2x plus 4. So m1 is negative 2. Right, and then y is equal to x minus 2. So m2 is equal to 1. Now we just take our n's, we plug them into the fact that tan theta, because it's the difference of two thetas, is equal to m2, 1, minus m1, negative 2, divide by 1 plus m1 times m2. So negative 2 times 1. That is the absolute value. So we're saying tan theta is equal to 3 over, you do get a negative 1, but we're going to call it a 1. So we're doing the inverse, the tangent inverse at 3. And that will give you an answer of 71.565 degrees, or 1.249 radians.
Mr. Rodriguez?
Yes.
Did you explain why you did positive 3 instead of negative 3?
Yeah, so that also goes along with the idea of adding the pi. We want to make sure that we are looking at the positive side of things. So this rule specifically applies the absolute value to make sure that we're finding theta in the domain, I'll say, that we want it to be in.
But like, how did you know you had to do that? Like,
It's formula based. That's given in the textbook as the formula for this. I didn't apply it on my own intuition.
I'm just like kind of confused.
All right, next concept here. This section is heavily formula based. Some of the stuff you've seen and it's applying it differently. Some of the stuff is a little bit new. The distance between a point and a line. And this is going to be like the perpendicular distance. So it might be hard to see, but there is a point right here. And there is a line in blue, obviously. And if we want to figure out what is this distance, D, from some point x1, y1 to some point on the line x2, y2. Okay. We are then using an equation of the line in this format, ax plus by plus c equals 0. So it's important that we rewrite it to that format. So we have our a, our b, and our c. The point that we are looking for, x1, y1, that is the point that stands alone. That is not on the line. The distance between the two of them, again, this is perpendicular. We need a positive value here because it's distance. The square root naturally will give us a positive with the squares. So it's a, the coefficient of the x term from the line, times the x coordinate plus b, coefficient of the y, times the y coordinate plus c, the constant value, over square root a squared plus b squared. So let's apply that example. Find the distance between the point 0, 2 and the line 4x plus 3y equals 0. So there is no constant term here, therefore c will take on the value 0. We've got the formula right here for us, so we have to extract key information. The a is the 4, the b is the 3, the x1 is the 0, and the y1 is the 2 from the ordered pair. So those are the, and c again is 0, so we don't really need it. So those are the key values that we're going to plug in to figure out what this distance is. So d equals absolute value of 4 times 0 plus 3 times 2. I'll put a plus 0 as a placeholder. Divide by square root 4 squared plus 3 squared. So we have 6 over square root 25, or 6 over 5. So if I were to sketch that really quickly, I would put that into y equals mx plus b, so 3y equals negative 4x, y equals negative 4 over 3x. So we are going through the origin, rise over run, so if I rise 4 and I run to the left 3, I have this line right here, roughly, and to the point of 0, 2, right there. So we're looking to get the closest distance in terms of the perpendicular, like altitude almost, right here. And that little kind of sliver is 6/5. Okay. All right. Last example for the lesson. It kind of ties a few concepts together here. And getting a picture will be helpful before we kind of get started on finding those answers. So a triangle has vertices at 0, 0, A, B, 1, 5, and C, 3, 1. Find the altitude from vertex B to side AC. So this is phrased differently than the previous example, but we do have to do the same kind of work, right? We're going to take the point B, the vertex B, which is a point, and match it to a side which would be a line AC. In this case, we're not given the equation of the line, we have to come up with it. So that would be the altitude. And it is a triangle, so once we have the altitude of the triangle, we have to figure out the area of the triangle. So we would also need the base length. Okay? So let's start with a sketch. So we have 0, 0, A. We have 1, 5. It doesn't need to be perfect, B. And we have 3, 1, C. And we want to drop an altitude here. It doesn't matter what that point is going to be. What matters is what that distance is. We know the point B. We know points A and C. So our next step would be to come up with the line for AC. Right, so line segment AC as a line. Well, we've got 2 points, so first thing we could easily come up with our slope. So our slope for that, change in y over change in x, right, 1 minus 0 over 3 minus 0. So you get a third. A point, 0, 0, great. So our line is just y is equal to 1/3 x. Okay with that? It's not in the format that we want for the formula that we need to use. We want to put it in ax plus by plus c equals 0. So I'm going to write it as 1/3 x minus y plus 0 equals 0. Okay? I don't love that, only because I know in my equation, my formula, I'm going to have to square that a, going to have to multiply it by something, subtract it. So then I'm dealing with a complex fraction with a radical in there. So can I make this even nicer before I go into my formula? What can I do?
Multiply it by 3.
Multiply it by 3. So then that makes this equivalent to x minus 3y plus 0 is still 0. So now I do have a clear-cut a, which is 1, a b, which is -3. My point that I'm working with is point b, which is x comma y, 1 comma 5. Okay, so our distance for the height of the triangle is equal to the absolute value of ax, so 1 times 1 plus by, so -3 times 5 plus c, or 0, divide by square root of a squared plus b squared, 1 squared plus -3 squared. So cleaning this up, 1 minus 8, -7, absolute value of that, 7, because I'm forming the same triangle essentially, I just wanted it in the quadrant that makes sense, over root 10, 7 over root 10.
I think the -3 is times 5.
Ooh, yes, thank you. So -15, 1 minus 15, -14, positive 14 over root 10. What did I do in my head? I did
You did
8. Yep. Thank you, Rowan. So if I have 14 over root 10, in the world of pre-calculus, you have to change that. In the world of calculus, if you have one good thing coming for you, you don't have to rationalize a single fraction in the world of calculus, which is kind of annoying because you're like, well, then why did I have to do every single time here? It's just not something that's assessed. It's not something that's expected. It's not even, you'll see answers 100% complete with radicals in your denominator next year. So anyways, here I'm going to rationalize by root 10 over root 10. I'm going to have a 14 root 10 over a 10, which is where, if I divide by 2, I get my 7 root 10 over 5. So that's the height. Okay? Now, in order to get the second part of the question, area of the triangle, what do we need to recall? Because we still have 1/2 base height. We need the base. What formula? Just the distance formula, right. So our base equals plain old distance formula between 2 points, which was the square root of your change in your x's squared plus the change in your y's squared. Right, so it's a little bit different than what we are doing for line to point. So point to point, here, we are using points A and C to get this distance, right? So we would have 3 minus 0 squared plus 1 minus 0 squared, all square rooted, so you have root 10. So now we have everything we need to come up with the area of this triangle. Put that up here, so our area would be equal to 1/2 7 root 10 over 5 times root 10. So that will kind of break down kind of nicely, right? Because I have 2 and 5 in my denominator. I have square root 100 or just 10 in my numerator. They all cancel, and I'm left with just the 7.